in chemistry, we do a lot of unit conversion problems. Sometimes we need equations, but there's a technique called dimensional analysis, which is using the units to guide the calculation. This is a very important skill to learn. You are all very capable of learning it. Some of you just might need to work a little harder at it. And so we're going to learn how to do dimensional analysis using some fairly simple units. Many of you can convert these units without writing all this stuff down. The point of it, though, is to learn how to do the dimensional analysis because, like I said, we're going to need it later. So we always need to include units. We treat units a lot like variables in algebra, like the letters. They can be canceled, they can multiply, be divided, etc. So a unit equation is a statement of two equivalent quantities. So we can say 2.54 centimeters is equal to 1 inch. That's just a statement of fact. That's the sort of thing you get from the table of conversion factors or relationships. And when we make a conversion factor out of that, we're making it into a fraction. What we're going to do is we're going to take one side of this equality and put it on the top and put the other side on the bottom. So we can write 2.54 centimeters per 1 inch. Or we could do it upside down, 1 inch per 2.54 centimeters. 1 inch is the same as 2.54 centimeters. So this is numerically equal to 1. The top and the bottom are the same thing. Anything divided by itself is 1. This is also numerically equal to 1. If I multiply something by 1, do I change its value? No. So this is the basic idea of dimensional analysis. We're going to apply conversion factors numerically equivalent to 1, and we're just changing the units. We're not changing the size. So, general form, you've got your information or your unit that's given, and then there's a unit that they're asking you for. In the simplest case, you're going to have one conversion factor in here, desired unit on the top, given unit on the bottom, because those given units are going to cancel out. So if we do a simple problem, how many centimeters are in 12 inches? So there's a number, 12 inches. It's got a unit. That's what I'm given. What am I desiring? What am I trying to find? Centimeters. So we can express this as a path. I'm starting at 12 inches and I want to go to centimeters. I want to find out. So you write that path out. And from that path comes the equation. I've got the 12 inches, and then anytime I have an arrow, I'm going to have a conversion factor. And these units are what go in the numerators. So I've got inches and centimeters. I've got inches, and this will be centimeters. And this unit, the unit I was given, is in the bottom here, because inches are going to cancel out and get out of there, go away. So the units tell me what to do, the dimensions tell me what to do. And then I need to know, well, what's the relationship between inches and centimeters? 1 inch is 2.54 centimeters. Could I say 1 centimeter over 2.54 inches? No, because that's not true. So then I've got 12 times 2.54. And my calculator says 30.48. The units canceled out, the centimeter, and I've got centimeters left. Now here's a question. How many significant figures? 2. 12 inches, 12, that's a nice whole number, right? It's exact? No, it isn't. It's measured. 2 significant figures. This relationship actually is exact. They redefined the centimeter, or they redefined the inch, so it's exactly 2.54 centimeters. But regardless, this would have more sig figs, and so this should have two significant figures. So the 3 and the 0. Can I say 30? That's ambiguous, right? So one way you can do this, you could put a decimal point there, because now technically that trailing 0 is significant. But it would be better to say 3.0 times 10 to the 1 centimeters. So we're going to sneak in some Sig Fig practice. So general problem solving strategies. Now read the problem. Identify the starting point. Write down all the numbers that you've been given with their units. Sometimes you'll have things like miles per hour or grams per cubic centimeter. That might be a conversion factor. Identify where you're trying to go. Figure out a plan of how to get from where you are to where you need to be. And then you solve. You follow the plan, use the calculator, do it twice. If the numbers don't agree, do it again. And then check. Does the answer make sense? Are the units correct? So this is a little bit like finding Starbucks at the Stanford Mall. I went there a couple years ago to meet someone, and you get out of the parking lot. I don't know where Starbucks is. So what do? You look for a map, right? So you walk along, and there's this nice big map here. So you look at the map, and what do you have to find on the map? The red circle that says you are here, right? Because if you don't know where you are, you can't figure out how to get where you're going. So you are here. Oh, I'm right here. Then I have to identify, where am I trying to go? I'm trying to go to Starbucks. Oh, Starbucks is over here. And then you figure out, well, how am I going to get there? Well, I'm going to go up here, and I'm going to take a right at that place, and there I am. A path. Then you follow the path. So this is like shopping at the mall, right? So some practice. Convert 288 centimeters to yards. I'm going to go over some of these kind of quick because I want to get to the harder ones later. So where am I? What's my starting unit? Centimeters. I'm starting with 288 centimeters. Where am I trying to go? Yards. How do I get there? Personally, I do not know how many centimeters are in a yard. Now, that yellow sheet over there might have that on there, but don't do that. I know how many centimeters are in an inch. So if I've got centimeters, I can go to inches. Do I know how many inches are in a yard? There's 36. Now maybe you don't remember that and you have to go from inches to feet and then feet to yards. That works too. There's not only one way to get to Starbucks at the mall, right? You could go this way or you could go that way. One way might be easier, maybe not. There's my path. That's the hard part. Unless you're already good at this, and some of you are, you need to write that down with the arrows. Because from this, it's easy. Every arrow is a fraction. I'm going to take this starting thing and I'm just going to copy it down 288 centimeters. I have 2 arrows, that means I have 2 fractions. I go to my path. Centimeter, inches, yards. Centimeters, inches, yards. I just copy the units down. I want centimeters to go away, so I'm going to divide by centimeters in the next term. Centimeters divided by centimeters cancel out. Poof, they're gone. I want inches to go away, so I'm going to divide by inches. Poof. You put all the units in first, and then you stick the numbers in. You don't have to worry, do I multiply by 36 or divide? You don't have to think about that. The units are going to tell you where to put the numbers. So here I have inches and centimeters. What's the relationship? 1 inch, right? So I put 1 in front of inch is equal to 2.54 centimeters. The units are telling me where to put the numbers. Yards and inches, what's the relationship? There's 36 inches in 1 yard. I can't say that 1 inch and 36 yards. Because if I stop and think about that for even a couple seconds, I realize that's dumb. What's on the top is equal to what's on the bottom. That's the same length, it's just being given a different name. So now I've got my equation. I would encourage you to follow this pattern. Start at the left, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, work your way across. Now obviously multiplying by 1 doesn't change anything, so you can skip that. But if it bothers you to skip the 1, go ahead and multiply by 1. It's not going to mess anything up. So I'm going to do 288. I can skip the times 1. I'm going to divide by 2.54. I'm going to skip the times 1, divide by 36, equals. My calculator's giving me a whole bunch of numbers. I don't want to write them all down. How many significant figures should this answer have? 3. Tricky. Okay, this one's exact because I'm telling you it's exact. Inches and yards, also exact. They are both English units. There are exactly 36 inches in a yard. So then I don't have to look at either of these when I figure out the number of significant figures. I'm only looking at this, so 3. So my calculator, I'm going to write down the first 3, and then I'm going to write down 2 more digits just in case I need this number somewhere else. There's the unit. And now I can go in and round it, and my final answer is 3.15 yards. Yes?
So are you just always going to have a simpler way to do it? Always have the same number of significant figures as the number that you're converting?
That's an excellent question. Okay, so I want you all to try to really understand significant figures. I know that's not going to happen. So what's more important is that you get close to the right number of significant figures. Usually, the way problems are set up on exams, in the textbook, the number of sig figs in the number you're starting with is usually the one that limits how many sig figs in the end. And an even simpler hack, if you will, 3 or 4 sig figs in the result is usually going to be okay. So in this instance, because both of these were exact conversions, it is just from the starting number. But sometimes the numbers we're multiplying by are not exact, and they can impact the answer. $3.15. So on this one, convert 9,255 cubic centimeters to gallons. So where am I starting? Where am I? I'm starting with the centimeters cubed. And where am I going? I'm going to gallons. How am I going to get there? Centimeters cubed is the same thing as milliliters. So I could convert to milliliters quite easily. I've got a metric unit and an English unit, right? That's the problem here. Yeah, I could go from milliliters to liters, and then liters to gallons. I'm going to have to go look that one up, right? Let's see. This is where things get a little messy. Way there. a gallon is equal to 3.785 liters. Yes?
So we're gonna have to memorize that?
You do not need to memorize this table. On an exam, I'll either give you this table, or the factors you need will be given in each example. So 3.785. So 1 gallon equals 3.785 liters. I had to go look that up. So here's my path. Sometimes when I do this in class, we end up with a different path. But this is what we've got. 3 arrows, 3 conversion factors, so 3 fraction. 9255 cubic centimeters, times in a line, times in a line, times in a line. The units in that path are what I'm going to write down now. I had cubic centimeters to start with, and then I go to milliliters and liters and gallons. And then I'm going to put cubic centimeters down here, so those cancel. I'm going to put milliliters down here, those cancel. I'm going to put liters down here, and those cancel. I am giving you a very specific set of instructions for how to do this. And if you follow the instructions, it works. Are there other ways to do it? Yes. But if you're not getting the right answer, just follow the directions. Okay, so I got all the units to figure out. Now I'm going to look up here. I had 1 gallon is 3.785 liters. That's the one I had to look up. So the 1 and the gallon go together. And the 3.785 liters go together. And they go together because I looked them up, and that's the way the book showed them. This is an often overlooked relationship. I pointed it out. I wrote it separate on the slide. A milliliter and a cubic centimeter are exactly the same thing. So a milliliter, 1 cubic centimeter. Same. Now here, I have a liter up there and I have a milliliter down here. So this is where I use what milli means. So if I look it up, because I haven't memorized it yet, milli stands for 10 to the minus 3, or times 10 to the minus 3. So in the denominator, I have 1 milliliter. So 1, and I'm using the abbreviation. In the numerator on the other side of the line, I'm going to put 1, and now instead of writing milli, I'm going to write what it means, times 10 to the minus 3. And then I multiply and divide, and I get my answer. Now, you could also say, well, yeah, but in that table, it showed that 1 liter was 1,000 milliliters. Well, that's true. It is the same thing. The problem with this is that sometimes students get confused about which unit is bigger, and they tell me that a milliliter is 1,000 liters. That's like telling me that an inch is 12 feet. No, it isn't. So if the metric system messes you up a lot, if you follow this pattern, write the unit and its prefix on one side, write the 10 to the something meaning of the prefix on the other side, it always works. It always works. I think that's pretty cool. How do you put this into your calculator? So 1 times 10 to the minus 3, calculators are a little bit different, but 1 EE negative 3. Some calculators have a button that's EXP, so you'll have to play around and figure out what yours is. So I'm going to do 9255 times 1 divided by 1 times 1 EE negative 3. EE stands for times 10 to the. So you don't multiply by 10 and then push the EE button. As you push EE, you say times 10 to the, and then you put in the exponent. And then I'm going to divide by 3.785. How many sig figs? This time it's 4. This is not exact, but it has 4 sig figs, and my starting number has 4. 2.445. Write down 2 extras. And then I'm going to round. Any questions? Okay, so conversions using metric prefixes. There's the directions. You put the unit with the prefix on one side, and on the other side you have the unit without anything. And you just look up until you've got it memorized. What does kilo mean? Kilo means times 10 to the 3. It's 1 kilometer. It's 1 times 10 to the 3 meters. That's when you have a base unit, like just a naked unit. Meter, liter, something like that. And then the other one is the same unit with a prefix. This is what you do. Prefix goes on one side, multiplier on the other side, you never put them together. If you have 2 prefixes, if you're converting centimeters to nanometers, could you do it in one step? You could, but you'd have to think about it a lot, and you might get it backwards and get it wrong. It's a lot simpler to just do 2 steps. Go from centimeters to meters, and then from meters to nanometers. So if you have 2 prefixes, do 2 steps. If you have 1 prefix, do 1 step. Convert 0.0043 liters to milliliters. So liters to milliliters. I have 1 prefix, right? I can do this in 1 step. 0.00423 liters. 1 step, I've got 1 factor. And liters to milliliters, and put liters down here, units cancel out. So in the numerator, I have milliliter. I want there to be 1 milliliter. And then on the other side, I'm going to write 1 and what milli means. Milli means times 10 to the minus 3. So 0.00423 divided by 1 EE minus 3, 4.23 milliliters. And some of you say, well, I can do that in my head. I just move the decimal place 3 places. Well, it's great if you remember which direction to do it. Learn how to use the metric prefixes in this very rigid, it's very rigid, but it's also very comforting because you do it the same way all the time and it always works. Just learn how to do it, and then if you want to learn how to do shortcuts, go for it. Here's 1 to 2 prefixes. 5.52 times 10 to the minus 5 centiseconds to microseconds. I have 2 prefixes here. I want to do 2 steps. So I'm starting with centiseconds, and I'm going to microseconds. In the middle, I want just the second, because I can go from centiseconds to seconds in 1 step, and I can go from seconds to microseconds in 1 step. There are questions on the worksheet where you have to do this. Okay, 5.52 times 10 to the minus 5 centiseconds. This one's going to have 2 fractions. I made a path. I'm going to just follow the path. Centiseconds, seconds, microseconds. I want to get rid of centiseconds from the first term, and so those are going to cancel out, and then seconds are going to cancel out. Get all the units in place. Here I've got centi in the denominator and nothing in the numerator. Well, what does centi mean? 10 to the negative 2. 10 to the negative 2. I'm going to write the multiplier, the 10 to the something, instead of the letter. 1 times 10 to the minus 2 seconds is the same as 1 centisecond. Over here, the prefix is on the top, so I'm going to write what it means on the bottom. Micro means 10 to the minus 6. There's 1 microsecond is 1 times 10 to the minus 6 seconds. We're following a pattern, so we don't have to think about it as much. Could you do it in a more elegant way? Sure. But my experience is that students screw that up. So let's just get it correct. 5.52 times 10 to the minus 5 times 1 EE negative 2 divided by 1 EE negative 6. Calculator says 0.552 microseconds. My conversion factors are exact. My starting number had 3 sig figs, the ending has 3. Sometimes we have units raised to a power, square inches or cubic centimeters. And for this, we use the same relationship as centimeters to inches, but then we have to square both of them. So we know that 2.54 centimeters is equal to 1 inch. So if we're doing squared units, we take that relationship and we square it. We square the number and the unit. And so we end up with 6.45 square centimeters is equal to 1 square inch. Because I have a 1 on this side and 1 squared is 1, we kind of forget that we are squaring numbers. You can't say that a square inch is 2.54 square centimeters. How many cubic centimeters in 2.11 cubic yards? What unit am I starting with? Cubic yards. What am I trying to get? Cubic centimeters. How do I get there? It's the same kind of path as if it was just yards to centimeters. So I could go yards to inches to centimeters. But because it's cubed, it's going to be cubic inches. .11 cubic yards, 2 fractions, because I have 2 arrows. Oops. So my next unit was cubic inches, and then I had cubic centimeters. Just following my path. Then I'm going to fill in the denominator so they cancel out. So cubic yards cancels. Cubic inches cancels. Now I'm going to put numbers in. What's the relationship between inches and centimeters? 1 inch equals 2.54 centimeters. But the units are cubed, so the numbers have to be cubed also. Inches and yards, 36 inches is 1 yard, but it's cubed. So 2.11 times 36 cubed times 2.54 cubed. Ginormous number. No. So 2.11 cubic yards. Sometimes, I tell you got to cube the numbers here, and then we want to get carried away and cube the 2.11. It's just getting a little too exuberant. If we wanted that to be cubed, it would say cubed. Or there would be parentheses, and the cube would be on the outside. But it doesn't say that. So my calculator is giving me this horrible number. 1613210.75. How many significant figures should it have? 3, because I started with 3. 161. But I can't just round this to 161. Most scientific calculators will change between scientific notation and decimal notation for you. And so you can take advantage of that and just change to scientific notation and then round it. So this is 1.61 times 10 to the 6th cubic centimeters. Any questions? I'm going to skip that problem. Density is a conversion factor. So density, there's an equation, right? When we calculate the density, we have to use the equation. You have to take the mass and you divide by the volume to get the density. But there are a lot of problems where they give you the density and they give you the volume and they ask you for the mass. Or they give you the mass and ask you for the volume, right? And then students put it into the equation and they rearrange the equation incorrectly and they get the wrong answer. You don't have to use algebra to do these problems. I did, yes, because we are so far over time. So, again, we're going to read the story. Backpackers often use canisters of white gas to fuel a cooking stove's burner. If one canister contains 1.45 liters of white gas and the density of the gas is 0.710 grams per cubic centimeter, what is the mass of the fuel in kilograms? Read all the words. Because, at the end it could say, do you like chocolate? Right? And then you wouldn't have to do anything. It's not going to happen. But okay, so then we're going to pull numbers out. So I see 1.45 liters. And I see 0.710. Those units are written with a slash because it's a heck of a lot easier to type it that way than to get out the equation editor and make it a vertical fraction. You're doing these problems with your hand, write it as a vertical fraction. This is grams over cubic centimeters. Then your brain will recognize that's a fraction, okay? So there's my numbers. I have to identify what I'm starting with and where I'm going. Well, I've got 2 numbers. I'm not sure where I'm starting. So I'm going to figure out where I'm going, and then I'll come back to that. So what am I trying to figure out? What unit? Kilograms. So I'm trying to get kilograms, and I have to start with one of these guys. So anytime you see per units, pointer's not working, grams per cubic centimeter, that might be a conversion factor. Liters, so anytime we see per units, that might be a conversion factor. Here, just liter, that cannot possibly be a conversion factor. So it's a pretty good guess that I'm going to start with liters, and I'm going to use this as a conversion factor along the way. So I'm going to start with liters, and I'm going to convert it to something, and then I'm going to convert it to something else, and I'm going to ultimately convert to kilograms. So if I look at this, I'm probably going to end up with both of these units, grams and cubic centimeters, in here somewhere. Gram relates very nicely to kilogram. Sometimes you start at the end and work backwards, and then sometimes you start at the end and you work backwards a little bit, and you start at the beginning and you work forward and hope that you can meet up in the middle. So I know if I got grams, I could go to kilograms. This is giving me a relationship between grams and cubic centimeters. So if I had cubic centimeters, I could go to grams by using that relationship, the density. And then there's a question of liters to cubic centimeters. It's in the table. This is a faster way to do it. What unit is exactly the same as a cubic centimeter? A milliliter. So instead of writing cubic centimeter, I'm going to write milliliter because it suits my purposes. It's the same. And here, instead of writing cubic centimeter, I'm going to write milliliter. Can I go from liters to milliliters? Absolutely. I've got my path. .45 liters times in a line, times in a line, times in a line. Liters, milliliters, grams, kilograms. Liters, milliliters, grams, kilograms. The liter is my first unit, and I'm going to stick that down here so they cancel out. Milliliter is going to go down here so they cancel out. Grams goes down here. Cancel out. My liter, milliliter, that's a metric conversion with one prefix, right? So on the top I have 1 milliliter. On the bottom I write 1 times 10 to the minus 3 because that's what milli means. At the other end, I've got kilograms and grams. I'm going to put a 1 in front of the prefix, and then on the other side of the line, I'm going to have a 1 times 10 to the, what's kilo mean? 10 to the 3. It's just memorizing what the prefixes mean, and you plug them in. This thing in the middle, grams per milliliter, that's the density. It's showing 0.710 grams, so I keep those together, 0.710 grams per 1 milliliter. This is using density as a conversion factor. It's a lot less thinking than using the density equation. So I want you to do it this way, at least at the beginning. So 1.45 divided by 1 EE negative 3 times 0.71 divided by 1 EE 3, and my calculator isn't showing me a ridiculous number of digits, so I can write them all down. The unit is kilograms. How many sig figs? 3. My starting number had 3. This conversion is exact. That one's exact. The density is not exact. That's also 3. 1.03 kilograms. Oops. I'll put those up as examples on YouTube separately. Sometimes problems involve an equation. Usually when that happens, there's one variable you have to find, and they give you the information for all the other variables. You plug it in and you solve it. An example would be something like this. You've got volume is equal to pi r squared L. they're giving you, they want you to find the radius. So they're giving you the length, they're giving you the mass, and what element it is, what the substance is, so you can use density to find the mass, find the volume. You can use density to find the volume, and you can figure it out. There you have to use an equation. Here's another one where you have to use the equation. Here's some extra examples on sig figs and cubed units.